This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. Is your mobile app really secure? New vulnerabilities pop up every day. Securing your app's valuable IP and data is critical. GuardSquare's security solutions are built for developers and protect your app at every stage in the development lifecycle. Multiple layers of protection automatically detect tampering and make your app a difficult target for attackers. Learn more at guardsquare.com/SERadio.
Hello everyone, this is Felina for Software Engineering Radio. Today with me on the show are two guests. The first guest is Kevlin Henney. He is an independent consultant, trainer, coder and writer, and he's given keynotes, tutorials and workshops at hundreds of conferences around the world. He is the co-author of A Pattern Language for Distributed Computing and On Patterns and Pattern Languages. The second guest today is Trisha Gee. She has developed Java applications for a range of industries in finance, manufacturing, software for companies of all sizes. Trisha is currently a developer advocate at JetBrains and leader of the Sevilla Java user group and a Java champion. Together, Kevlin and Trisha edited the book 97 Things Every Java Programmer Should Know. Welcome to the show. So I just read your book and it's really packed with super interesting facts and information. Even though I am not a Java programmer and have never been a Java programmer, I really learned a lot. And many of the tips are also very generic in nature. So my plan today for the show is that I just ask you about a few of the 97 things that everyone should know. And afterwards, we will also ask you about your favorite things to know. So one of the chapters that I specifically liked is chapter 5 about encapsulation. And the author of this chapter, Edson Yanaga, argues that encapsulation is actually one of the OO principles that is used least. So that's actually the first thing that I want to dive into a bit. What is encapsulation? Because if it's not used so often, people might also not be so aware of what encapsulation is.
The way I'd put it is, and the way Edson kind of explores it, because the specific title of his piece is Behavior is Easy, State is Hard. And it's this idea of this kind of relationship that we want to get out. That when many people think about encapsulation, they just think about a kind of a light veneer, just make a few things private. Yeah, make the fields private, that's it. It just kind of washes over it. I've kind of scrubbed a little bit of private on the data and we're all good. Whereas actually what's really going on for encapsulation is this idea of how do I use it? What's the interface? How do I want to use it? And there's something much richer that's going on there. So often as developers, we tend to think from the inside out. You know, you're presented on the screen, here are my fields, I can see everything, I have a privileged view. Whereas from the outside, you don't get that. And so we tend to think, oh, my fields, I'm going to add some getters and setters, rather than thinking, what's this object for? How do you use it? What is the intention behind it? And these are far, far harder questions. And that is what guides the state of changeable objects, for example, rather than thinking like, nudging flags here and collections there. So often you look at Java code, and in some systems you get a feeling, yep, there's collections and there's strings and there's integers and there's flags. You don't really get a sense of things in a capsule, quite literally encapsulate. To put something in a capsule means there's a boundary, and we want to care about how do we look at that boundary, the interface, and what are we hiding away from people? It's not just my choice of data representation, it's the mechanics, if you like. So that's really what he's getting at. And you can see that's a lot deeper than I guess many people think of when we think of encapsulation as, oh, it's just private fields, that's it. It's a bigger story, and therefore it's more complex.
I think something else that was interesting from that piece was, so he mentions at the beginning, he mentions polymorphism and inheritance. And I think one of the anti-patterns that's quite common, especially when you're learning to program Java, is kind of the opposite of encapsulation, using inheritance to just kind of like grab everything and expose everything. So my object is one of everything. It's like the opposite of encapsulated. So I think his point was very interesting about how, And I've been in interviews where I've been asked about polymorphism and inheritance and not been asked about encapsulation, about things like, do one thing and do it properly and only expose the things which are important to the person using this object. So yeah, it was an interesting piece there.
So can you give a concrete example of a use case or a business case where the situation that Kevlin just described occurred, where you had code that indeed just painted a little bit of encapsulation on top of code and that you maybe changed or refactored into using encapsulation as Edson Janaga argues here?
I'm not sure I can think of a specific one. I can think of this happening a bunch of times where, especially using inheritance, where you think you have, let's say, a book order object, but because it's using inheritance, it also has like a bunch of other order type characteristics. And you see this, sometimes it's bled over from a relational database where your relational database has like flags for is not one of these, is one of these, isn't one of those, does have one of those. And sometimes you get it because you have this enormous inheritance hierarchy whereby you're basically like, I think the example in design patterns was about hierarchies for ducks. And so when you have like a rubber duck that doesn't fly and it doesn't quack, it squeaks, but it probably has a does fly or does quack type method on it. So the user, have to figure out like, what is this object, which is the opposite of object-oriented programming, whereby you should just get a rubber duck and not care about all of the other types of ducks, which may or may not be blurring into its type.
Yeah, I think that's one of those areas where you can kind of, again, specific examples. In most cases, it's not just uniquely because something was unencapsulated. Normally, there's a bunch of other things going on. And it starts with the question when somebody says, is 100 fields too many for a class? And at that point, just from the question, you already know something is amiss. And in other words, that you've ended up with something that is just aggregated data. And as Tricia says, sometimes it's just like, yep, I've taken the database, it's just like straight in. I've just taken the schema. And rather than saying, you know what, some of these are behavioral. A flag is normally an indication of a behavior. It's a kind of thing. But there's no subtyping in the database. So we don't end up with that rich model in the code. We end up with a very flat model. It's just basically sort of data transfer objects with a couple of other methods. And there's a lot of data. There's these buckets of data. And then that kind of style permeates through the rest of the code. And then somebody comes to maintain it. They add a thing. Maybe somebody else has got the kind of like, yep, I've got the inheritance hammer. It's my turn to hit everything with it. Or I've seen the idea of like, well, I've reduced the number of fields here by pushing them up into superclasses. And it's like, actually, that might have made the problem worse because they're all still there, but I can't see them directly. And now I've got protected data, which is, so in other words, it's normally symptomatic of something else. It's very rarely just the one thing. So I think that's the thing is normally what you do is you find one spot, you kind of pull and you go, oh, okay, this is connected to this, is connected to this. Yeah.
So I said that many of the things that people should know are not so Java specific, but this chapter actually has some Java specific advice related to encapsulation, because the chapter says that you should not auto-generate setters. So why is this good advice? Why does this help the code to be more encapsulated?
Behavior is easy, state is hard. Because once you start having setters, once you start having mutability, then you can't make any reasoning about what the behavior should be, because sometimes the behavior is based on if I've got one of these or I don't have one of these or this isn't null or that is null. You're mutating when you're mutating the state of an object, it becomes very difficult to reason about what you've got and how it should behave. And in fact, some of this is Java is changing to become more immutable first. It's not really as far as immutable, but like final first or no setters first, like records, for example, which is a new feature in Java 16, you can create a new record instance with new fields, but you can't set those. This is like basically an immutable object where you don't change things but having mutability there to begin with by default was one of those things which led to some of these anti-patterns that we're talking about, some of these bugs which are difficult to debug. Like, I don't know, now this object has been through these various workflows, I don't know what it is or how it should behave.
Yeah, and I think that is that issue, is that culturally we had this kind of much more imperative mindset that immutability is a thing you ask for, mutability is a thing you get for free. And we kind of moved into a very different time here where people have started thinking, you know what, there's a lot of reasons that's not true. But that challenge, the setters, the auto setters, even if you have something auto-generating setters, and that's the problem, is we've ended up with saying, well, I always have setters or I often have setters. It's become such a ritual that people auto-generate it through their fingers. If nothing else is going on, they'll do it through their fingers. You don't need a tool to do that. They don't even know that they're doing it. So often what you'll end up with is that kind of addition, that kind of like, yep, I'm putting this here. And perhaps if you were writing this if you were focused on the tests, you would see that and go, wait a minute, why am I doing this? I've got a setter, but I've never tested for it. And it's that simple idea that asking a question is easy, but changing the world is a lot harder. The way that you can change an object is often subtle, and you can put things into invalid states. And therefore, you end up propagating code elsewhere that should probably be either not there at all or should be contained, encapsulated within the object. The encapsulation boundary is, I'm looking after the state. I'm going to make sure either it doesn't change or it changes in very well-defined ways. And I shouldn't have other people in the workflow going, hey, can I just check in on you at this point? What state are you in? The nightmare scenario is a piece of code that I saw a few years ago, that it suffered all of these things. As I say, it's a system of issues. It's never one issue. It's normally a system of things. Big classes, long methods, lots of hands in the code, lots of very quick changes. So there was no kind of sense of architectural consistency or style. Everything was kind of in panic mode. But that also led to the feeling when you were reading through the code that if you asked me, what does this code do? I would probably say, I wouldn't say, oh, it quotes for mortgages, which is what the system was supposed to do. I'd say mostly this code checks for null and it logs. Because it was forever, wait a minute, I wonder if this is still null? It wasn't null 1,000 lines ago, but maybe that's changed in the last 1,000 lines. There was a complete sense of, we'd lost the model, as it were. There was no sense of reasoning. And as Tricia pointed out, this kind of idea that you should be able to reason about your code. So you kind of lose that, and then it just becomes, well, I guess in these times we could say viral. It just spreads, and that becomes the symptom in the code. And that's that idea. Again, encapsulation, it's a boundary. It's trying to keep things contained. And if your rule is nothing changes, then that's where the containment comes. If your rule is things only change in specific, well-defined ways in the way that other objects can use it, rather than how do I change an int, how do I change a Boolean, that's quite different in that sense. People are often tackling it at the kind of like the flag level rather than what makes sense for this object. And those setters often don't have the right validation. So you can quite happily put an object into an inconsistent state, which kind of, that's kind of not an object really.
So I think to summarize, the advice is that you shouldn't auto-generate setters, because setters is something you should really consider. You should really think, what is it that I want here? What should and shouldn't happen with this object? If you just generate them, as you said, as a ritual, you just make them either automatically or you just write them by habit, then you aren't thinking about, you aren't modeling, or you're just adding some plumbing.
State change is a privilege, not a right.
Nice. That's a great quote. So I want to move on to chapter 6. Chapter 6 is about breaking up problems into chunks. So firstly, I would like to hear, what is your summary of this? Because clearly breaking up a problem into separate pieces, that's a good thing. But what is the core of this chapter?
I really like this chapter from Jean because it's a common thing that you hear, when you're doing small pieces of toy engineering, obviously you've got small pieces of work that you can do. You can break stuff into chunks. When you do real engineering, it becomes much more difficult to break a user story down into discrete tasks. I think there's sometimes confusion between breaking down something into small pieces of business value, which can be difficult to do, and breaking something into small tasks, which can be implemented and checked in without breaking the code or without making any major changes. And so this is something that she's kind of talking about in this piece, that we as developers can often end up working on a piece of code for 2 weeks, on a business piece of value for about 2 weeks. And at the end of it, maybe we've changed, I don't know, maybe only 3 files, maybe 100 files, but we still haven't been able to make the smallest possible commit to source control, or we still haven't been able to hand over to someone else. And that's because in our minds, we're like, well, this is a special piece of work. It's got all these dependencies and it's not ready until I've done everything. But in this piece, she takes a couple of examples and shows how you can be look, you can break it down into, I'm just going to I'm going to output something to the command line. I'm going to read something from a file. I'm going to iterate over it. I'm going to make this filter. I'm going to do this change. Just because it doesn't change the functionality in the application as a whole doesn't mean it's not a small committable piece of work. So you can still commit the piece of code which reads from a file, even if you don't do anything with that file yet. You can still commit. I'm a big fan of committing like skeleton code, like sketching out code. Like perhaps you've got unit tests for maybe even larger sort of functional level tests, but they're not hooked into your main application yet. So you can kind of sketch out pieces of functionality the user's never going to see yet because you haven't plumbed them in. But you can break that down into smaller tasks and commit them. It's definitely is a skill. It's a difficult thing to do, to break your work down into small tasks. But just because it's difficult doesn't mean it can't or shouldn't be done.
So then how do I know what is a committable piece of work? So I'm programming and I'm adding a bit here and there and I'm adding a new feature. So this class needs to change. How do I stop myself from committing this whole blob of changes?
When I worked at LMAX, which I worked out in London 10 years ago, and I worked with people like Dave Farley, who wrote the Continuous Delivery book, and Martin Thompson, who's now fairly famous for talking about mechanical sympathy. And I worked with all these great people who were very well steeped in extreme programming and agile stuff. They kind of taught me some of this stuff. Like one of the ways that you know that it's ready to commit is you can have a unit test. So you've only added a couple of lines of code. Like I said, it's not plumbed into perhaps the user interface, but I've written a method which exposes some functionality and I have a unit test. It compiles, the test passes, the build passes, I can commit that. And you can do that with just like 2 lines of code, or in Java, probably like 6 because methods are quite long. But you just do it on a small few lines of code basis. And the thing is that if you have unit tests, and we also had end-to-end acceptance tests, if you have unit tests and they pass and the end-to-end acceptance tests pass, then you can commit. It's safe to commit. You can do that.
I think that idea of the couple of points that Tricia mentioned, which are really key in terms of that workflow. The first is that idea of, can we break this down? It is a skill. You can break this one down by learning to do it. Often when we approach things, we have one big idea in our head and it becomes an act of almost performance. I must do it all at once. It's all in my head. And I'm now going to be glued to my keyboard and it's going to flow from my head through my fingertips with the assistance of pizza and coffee and all the rest of it. It's a performance act. Rather than thinking, okay, what's the next bit? What's the next small bit? What's the bit that moves it towards that? And the way that I work with clients in this, I always say, well, what's half of what you're thinking? You're thinking something big. What's half of what you're thinking that is still reasonable? Okay, and what's half of that? And then that other point about the really simple point of, does it work? Not does everything work as I am planning for it to work at some point in the future, but at this point, is it a meaningful step? And honestly, the bottom line is, so Trish is talking about all the really good stuff. Let's just start with the really simple stuff. Does it compile? Okay. Honestly, I've seen things in version control systems you people wouldn't believe, and they wouldn't compile. So, the bottom line is, does it actually compile? That really has to be the simplest thing. And then moving up through various versions of it works. The very simple idea of, I've added something. And is it meaningful is, well, could I describe what I've just done? Well, yes, I've just added a method here, or I've added a special case. We're not exploiting it elsewhere, but here's a piece of code in the test that demonstrates the existence of that special case handling, and that's fine. That's a stepping stone, which I think is the other thing. Is there's an older term for it. I picked this one up off Grady Booch years ago in one of his books, about 30 years ago. Stable intermediate forms. Oh, just for the listeners, by the way, I'm only in my 30s, of course. I was just very precocious as a child. But I was reading this stuff, and there's this lovely phrase, stable intermediate forms, that he got from Herbert Simon, economist and general polymath. And this idea of stable intermediate forms, that although you've got a big goal in mind, rather than having some big bang moment where everything comes together miraculously or not, what are the intermediate forms that also work? It's like walking versus running. When you walk, you always have at least one point of contact with the ground. Therefore, you are stable. You can pause and it's safe. If you run, the definition of running is that you go 0, 1, 0, 1. And there's something very binary about that. And developers do love that. They love the running. I must do it all at once. But if you trip, the whole thing falls apart. If you're distracted, the whole thing falls apart. If it is not all complete, then you don't have a thing. Whereas with walking, it's like, okay, I can pause now. Yeah, I can check that in. I can do whatever. It's en route. And it's stable, it's good as it is, rather than, oh, please don't use that. It's all kind of hanging, it's all hanging by pieces of string and good hope. So that is that idea that, and I think Jean's piece is really good in kind of highlighting this and just starting, it's also quite good in terms of her storytelling, which I think it really brings the piece to life.
Moving on to the next chapter, one chapter that also caught my attention is chapter 21, because that chapter is about thinking in SQL or thinking like you would in SQL. So I was a bit surprised. I was like, well, this book is about Java, but now you're saying I should think like I should use SQL thinking. So what is that? What is SQL thinking?
It's logical, isn't it? So that's Dean Wampler's piece. And what I like about this is a lot of what he's talking about, he's leading with SQL, but what he's really, in one sense, talking about is declarative thinking, if you want to open it up. And it's just that SQL is our natural hook. It is the logic programming language that most people know that they don't know that they know as a logic programming language. So it's just that opening idea of like, how would I ask a question? I've got a whole load of data. How would I ask a question? Well, you know what? Let's set up a for loop. No, that's not how we'd ask the question. You start framing it. I want to select things. Tell me the criteria that matter. Okay. So it's kind of flipping away we might say at one level it's inverting the control flow, but actually what we're trying to do is discard the control flow and say, you know what? You've written loops all your life. You have written all the loops. As a developer, you have written all the loops you will ever need to write. You've written the loop where you do something for everything in a collection. You've written the loop where you search for something. There's only a handful of loops, and you have written them all many times. And there's this idea of like, well, what's your intention? And it's that idea that he's trying to get us drawn into is like, what is the intention of this piece? I am trying to select these from where? Well, okay, under what conditions? What's the thing that matters in this? And really to look at our collections and our data sets from that point of view, which naturally leads you into kind of, there's the broad declarative space, but it naturally leads you into thinking in terms of streams. It naturally leads you into having a better relationship with your collections, I guess, rather than poking and prodding them with for loops and ifs. It's kind of like, what's our goal here? Let's figure out the flow, but not the control flow. Somebody else has already done that. And that kind of thinking is quite powerful. So that's the thing, as you say, hey, what's this SQL thinking in the middle of a Java book? It's like, what he's trying to do is make you recognize you already know this stuff, but perhaps haven't had the opportunity to bring it home. You do it in one language.
Talking about bringing it home, bringing it to Java, because as a former C# developer, I of course think about LINQ, about actual language features that enable this SQL-like thinking. Is there something like this in Java? Are there language features or concepts that support this form of thinking?
Yeah, and it's fairly recent in Java's history. So Java 8 got the Streams API, which Kevlin referred to. So finally, we could, instead of iterating over and pulling stuff out of our collections, we could say, for every one of, well, actually the worst one is for everyone, do this thing. But better would be to like filter this collection for something which looks like this, order by this, And so Streams came in Java 8. And that's one of the things that really helped me get my head around Streams when that came in was thinking about SQL. The fact that you would be like, instead of, you don't tell the database how to get its data, you tell it what you want. And kind of turning the thinking on its head was what was required to understand how Streams worked.
Yeah, and there is a difference in the sense from C# because the LINQ stuff, if you like, it's the way that streams are represented. So the two things happened in Java 8. One was the streams and the other was lambdas. That gives you that richness. And those were in C# sooner, but LINQ added an additional layer of sugaring over the top. If you like, what you get in Java, there's no extra language support, but it's the LINQ unlinked. In other words, if you delink it, you start looking at what's there, the dot where and all the rest of it. That's what you're getting in Java, is as if you're writing the raw version rather than the syntax sugared version. That's the distinction there.
The next chapter that I want to talk about is chapter 43 about type inference. So as I said, I'm not much of a Java expert. So I actually learned from this chapter that since Java 11, there is local variable type inference in Java. What is that? What is local variable type inference?
It's just a long way of saying that you can type VAR instead of your type name on the left-hand side. So there's always been a lot of criticism about Java being full of boilerplate. And one of the things is, for example, like in the very old days, you used to have to say list string my list equals new array list string. And everyone's going, why do I need to say all of those things so many times? Java 7 introduced the diamond operator, so you didn't need to say the string inside the chevrons, inside the generics on two sides. And technically Java 10, so it's in Java 11, introduced local variable type inference so that you can now just say var my list equals new array list string. And it does what it says on the tin. It's type inference. It's not, one of the misleading things is some people think it's a bit like Groovy's def, where you kind of have a kind of fluffy type with dynamic typing. But it's not. It's like, if I can tell from the right-hand side what the type should be, I will use the right-hand type instead of you having to literally type it 2 times on each side. But it's local variables, so it's inside methods only. You can't use it for fields. You can't use it for parameters. You can only use it for variables inside your methods.
And I think that's quite nice from that point of view, that it's a kind of agreement it's a kind of like a three-way agreement. It's you, the code base, and the compiler. It's like, you're looking at it, you go, I know what the type is. And the compiler's going, yeah, I know what the type is. And it's just like, well, why do we have to tell the source code the type? Because you and me have already agreed on this. I can tell. Look at the thing on the right-hand side. We all know what it is. Why do we have to spell it out again? So there's that, but it's got a little bit of restraint. And that's the point that Trisha said. I mean, it's just like, what if I put this everywhere? If it's local, then I can see everything that I need to. The minute I start hitting the field level, it becomes a little more brittle, both from the reader's point of view, but also some of the changes that you could accidentally make in a field initializer that suddenly changed the representation of your class, which is probably not what you planned. So there's reasons to put a little bit of restraint and say, you know what, in the privacy of your own method, we're all good. We can see stuff. Everybody knows, and there's very few surprises or opportunities for surprise. So there's kind of like an agreement with that. And so it does ease sometimes when people describe the language is strongly typed, it's just like, yeah, and I'm typing, and I'm typing, and I'm typing. There's a lot of letters there. That's why we have auto-completion, because there's a remarkable amount of typing otherwise. And really, that's still heavy on the eye. So it just eases that. And we see this in a number of other languages. You mentioned C# before that. That had that. We find that in functional languages with Hindley-Milner type systems. C++ got an equivalent thing. Everybody's kind of going, I think we've gone through the idea that we all know what we're talking about. Let's let the source code acknowledge that too. So it picks up on a valuable trend there.
So I think what you're saying is that it doesn't only save you time in typing and actually typing the characters, but it also makes your code more readable because you don't have this double irrelevant information that you still have to process.
Yeah, you have to do one of the things that, if you like, that has happened since, there's a few features that allow the code to find its way a little bit further left towards the reading line. There's a lot of Java code that kind of wanders off the right-hand side of the screen. It's just like, oh, come on, hold yourself back in. We're still human. We still have a limited ability to read really long things. And it just shortens lines, makes things accessible and readable. The most interesting thing is normally the variable name. What role is, I'm going to see this variable name again many times. So it's introducing yourself. Hi, I'm this variable. Guess what? This is what I'm initialized to. And, I take my type from that, rather than here's a whole load of ceremony, like giving somebody a whole load of honorific titles up front, and we still don't know what they're called. It's just like, I am senior principal, da, 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 da. Yes, but what's your name? What do I call you? It's now, okay, hi, I'm Fred, and here's all the other stuff should you care. It's not hidden away. It's all there. It's just that we avoid having to repeat it and we put it in the right place.
Yeah, that totally makes sense.
Elastic enables the world's leading organizations to put their data to work using the power of search. Whether it's connecting people and teams with content that matters, keeping applications and infrastructure online, or protecting entire digital ecosystems, Elastic's search platform is able to surface relevant results with speed and at scale. Learn how you can get started with Elastic's search platform for free at elastic.co/SERadio.
moving on to chapter 54. This is your own chapter, Trisha, because many of the chapters are written by your co-authors, but this is your own personal chapter in which you argue that your IDE, and then specifically JetBrains, can do a lot for you. So I'm really curious, what are some of your favorite tips? What are things the IDE can do for me that I don't know yet?
So I have so many tips for using the IDE that most of my conference presentations are about how to use the IDE. We had a whole IntelliJ IDEA conference last week, which was 2 7-hour days of content on how to use the IDE, which should be available on YouTube if anyone's interested. But I'll try and restrict us to a small number of features. We were talking earlier about things like type inference, where it makes the code easier to read sometimes, but sometimes losing that typed out type information makes it more difficult to read. The IDE can help you read your code with things like type hints, both for local variable type inference and also for things like parameters that you pass into methods. So for reading code, navigating code, the IDE is really, really helpful. Generating code, we talked a bit about why not to generate code, why not to generate setters, but in Java, there are times when you are going to want to generate getters, setters, hash code, equals, constructors, toString. And there is really no need to write that stuff out. The IDE will do it for you. So by all means, just use the code generation features. Another part of code generation that I really like inside the IDE, and again, it comes back to the fact that I like writing unit tests. I like to write my unit tests first. I like to write the test to code against the API the way I would like it to be. So instead of using your classic IDE features, which is code suggestions and code completion, do the opposite. Type out all the code the way that you expect it to be. And if the IDE says this method doesn't exist in the shape that you made it, then it will create that code for you. So that allows you to think outside in. It allows you to define the API the way it makes sense from the calling point of view, instead of writing the internals of the class and then trying to expose it in a sensible way. So I like that kind of outside in code generation. Favorite features as well. See, I told you I could go on about this for ages. Refactoring, particularly inside IntelliJ IDEA, but all of these features are available inside your favorite IDE. It doesn't have to be IntelliJ IDEA. But the refactoring tools, renaming, you should not be doing a search and replace. You should be using the refactoring tools to rename your methods, your variables, your classes in all the places they need renaming. And no, the IDE will do it correctly, so everything still compiles. These automatic refactoring tools mean that everything compiles. You don't have to recompile and fix things up afterwards. And that's what you can rely on your IDE to do. Your IDE uses the compiler. It uses its own internal logic to figure out, what is the right way to do this? How do I keep the code green and make everything still semantically the same as it was before? So refactoring is one of my favorite things. And then just one last thing in IntelliJ IDEA specifically, the inspections. So inspections cover a whole broad range of things have you thought about doing this for loop as an enhanced for loop instead of an indexed for loop? It does things like, now you're using Java 8 or beyond, you could use the Streams API. And in particular, I like the fact that the inspections in IntelliJ IDEA will help you migrate to modern versions of Java. So it will tell you things like you can use the Streams API. Java 8 isn't so modern anymore, but Streams API, you can use local variable type inference. So you can use var if you want to. New features which will be coming in Java 16 include records. We already have records and pattern matching for instance of. And we now have things like text blocks and switch expressions. These are all things which kind of help get rid of some old-fashioned looking Java code and turn it into something more readable, more succinct, and just generally prettier. And the IDE will just say, did you know you can use the new features in Java? So you don't need to go and find that stuff out. So the IDE will do that for you. So that is a not so quick summary of some of my favorite features inside the IDE.
So then, Kevlin, it's only fair if you also get to talk about your chapter, of course. So your chapter is 85, and your chapter is about checked exceptions, which is a really Java-specific thing. So firstly, for the people in the audience that aren't Java programmers, what are checked exceptions?
Right. Checked exceptions are exceptions that the compiler will check. As opposed to the runtime. In other words, there's basically anything that derives from anything that subclasses from exception, or actually throwable but it's not also a runtime exception and is not an error. In other words, these are kind of like platform level errors, and runtime exceptions are kind of like the ordinary small change exceptions that you might expect. Oops, I indexed past the end of an array type exception. Oh dear, I seem to have dereferenced a null type of exception. In other words, the small change ones, the ones that are likely to happen everywhere because they're going to be really noisy, they get an exemption from this. There was this idea with checked exceptions of why don't we make the exception modes of a method? Why don't we make that part of the type signature? And this is one of those kind of ideas that sounds initially quite good. It's quite well intentioned. In other words, the regular signature of a method gives you the happy day behavior. I pass these arguments in, I get this result back, we're all good. But what happens when it goes wrong? Well, let's acknowledge exceptions as first class in that sense and have a throws clause that shows you the exceptions that are thrown. This is great in theory. First language that I know of was that did this was Barbara Liskow's Clue language. So 1970s, that language hugely influenced languages after it with exceptions. But there's this idea of you making it part of the type system. And then you start trying to build things. You start trying to build larger code bases. You start trying to build things that have interfaces that evolve and that you give out to other people. And it turns out that having the checked exception there becomes an annoyance because the compiler will not let you not handle a checked exception. If it sees you're calling a method with a checked exception, it will say, well, either you need to catch that in this method or you need to republish that exception in your own signature, which unfortunately has led to a lot of code where people just simply catch and kill. It's just, oh, this is so annoying, I'm going to turn the compiler off. Or they just catch the exception, wrap it in a runtime exception, which, as it were, is stealth mode, and bubble it up anyway. And the point here is that in large code bases, it has turned out, and this is an important thing, this is a feature of the Java language. It is nothing to do with the JVM. The JVM is utterly oblivious to this kind of stuff. Other JVM languages don't use it. The experiment was an interesting one, and actually I'd cite a C# rationale. C# doesn't have them because of the Java experience. It's kind of like, yeah, we saw what happened there, it didn't work out. We understand that it's not like the type signature. I think the way that I tend to put it is Tolstoy's Anna Karenina. All happy families are the same, but each unhappy family is unhappy in its own way. It turns out that the ways in which you might want to classify failure are quite variable and change over time, even though the happy day scenario might remain stable. You might, and we suddenly discover there's also a loss of encapsulation, to refer back to our opening consideration, is like you start perhaps unintentionally, but in a larger code base with lots of developers, it evolves that way. You start publishing details that are actually quite private. It's, oh, you're throwing that kind of exception, are you? Okay. So it becomes a real grind, and it starts adding to the boilerplate that Tricia was talking about. You end up with a lot of stuff. Either you're killing these exceptions or you're having to republish them. And every time something changes, your interface suddenly become unstable, even though its intention has remained stable. So it's one of those things, great in theory, but not great in practice. And that became, it's that idea. Also, when you start doing plug-in architectures, there's a lot of issues there. And having code execute through things, again, whose exceptions do I need to publish? It starts becoming an unnecessary set of negotiations for code that would otherwise work. And Lambdas also kind of came along, well, a bit later, but nonetheless, it's that case of like, well, the Lambda syntax is intentionally light. It takes a very different philosophy. And so there's this idea that in many projects anyway, there is this idea of like, yeah, we don't use checked exceptions anymore because they're a bit of a burden. We only use the ones that exist in the platforms that we're using, but don't make your own, is basically the advice. But the reason that advice is there is because still we find people are taken with this attractive idea, this idea that in theory this is a good idea, and advocating it's just like, okay, so my piece is called Uncheck Your Exceptions. It's just like, yep, it is a nice idea in theory, and nobody's doing anything because they mean to cause problems for API evolution. But actually, in practice, we've learned that, and every language that's been around for more than a few minutes has picked up something that it's probably regrets. It's like families. It's just there's something there. There's a sense of regret. Of like, yeah, okay, that was a nice idea. Didn't work out, but we got other ideas that did.
So your advice, in short, is just don't use checked exceptions if you can avoid it.
Yeah, you're creating your own. Don't go down the path of creating hierarchies of checked exceptions, because we end up trivializing them. What you end up with is people create code. And they say, oh, well, it's such a burden. Tell you what, we're going to have my library exception, and all of the things will basically inherit from that. And then you end up losing the original intention, which was to be specific. You just say, yeah, we're just going to throw the root exception and we're going to put that in the signature. It's like, well, we've actually lost that utility of it throws an overflow, it throws an underflow, and that's it. It's now, it throws something from a library and it's tended towards the top. And in the worst cases, you'll just see people go, throws exception. There we go. That should cover all sins.
There's one more chapter that I found specifically interesting, and that is chapter 81 about coroutines. Coroutines are described as lightweight alternatives to threads in Java. But I think many people might not be aware of what coroutines are. So let's start with that. What are coroutines, and what is an example of a situation in which a coroutine could be useful?
One of the things I liked about this chapter is it actually explained coroutines to me for the first time. And I was like, oh, now I get coroutines. So I definitely want to recommend people actually read that chapter in the book and it's specifically coroutines in Kotlin. And so it's a JVM language. Something Kevlin and I wanted to put in the book was not just Java, the language things that Java developers needed to know, but things from other JVM languages, especially because some of those features may find their way into Java, the language in the future. But I think a lot of Java programmers like me are like, I don't really know what coroutines are or why they're useful.
Yeah, I think the thing about the coroutines is really nice to get that because we were hoping for this language diversity, but then to get something very specifically on coroutines is nice because coroutines are kind of making a bit of a comeback. And it's one of those things of, I think, a number of languages in the last decade have kind of added them in, Kotlin being kind of a poster child for this. Python formally acknowledged that it had them. It had them all along, in one sense, generators and things like that, but properly, formally acknowledged that it had them. And we're seeing these kind of features creeping in to languages. And what I love about this is that coroutines are really old, and they were just fading when I entered the workforce. And I say this as a young man in his early 30s, of course. When I was entering the workforce, they were just kind of going out. And we were at the point where process creation was becoming cheaper. People were talking about processes. We were also moving to event-driven architectures. And then we were on the cusp of threading, and then threading became a big deal. And, there was that. And that kind of it was the question of like, how do I express the idea that I wish to have concurrent activation of things? Not necessarily, we're talking pre-multi-core, not necessarily actual true parallelism, but at least concurrent activation. I don't want to have to keep starting up and shutting down state machines to remember a thing that I already had. And coroutines used to be part of that answer. And they're a very old mechanism. Melvin Conway, who is the same Conway as in Conway's Law, and Conway's Law was identified in 1968. Melvin Conway invented the coroutine in 1958. So not a new idea at all. But they used to be the only way to really express this kind of idea. And they used to be part of the object paradigm. So Simula 67, one of its big deals was, well, objects exist in the world concurrently with one another. You don't leave an object and it loses its memory and its state. You can go back to it. So Simula had coroutines. So it was there all along, but we've had so many other mechanisms that have come into languages that we kind of displace this. But what's nice about coroutines is they are simple. You don't get race conditions. You don't have all of that, oh, I need to remember to synchronize this. I need to remember to lock this and unlock that. You can't have a race condition with a coroutine. It just simply says, I guess you were after an example. A very simple example is just simply that idea of, okay, you're Alexa, I'm a parser. You break down some tokens and I'll figure out where they fit. And it turns out that just give me the next word is a classic example. Just give me the next token. Give me the next token. I don't know what state you're keeping about that. You don't need to be a full-blown object. You're just running a loop. But the fact is that loop shouldn't have to be spread across multiple methods. It's a loop. I'm going to return you something. We don't want to lose the loop state. So people choreograph all kinds of difficult code around this. And in fact, I think most of the kind of SAX code that was written in the late 90s could be eliminated with coroutines, simply because it's a case of like, I just want the next thing. That's it. You've got state about how to manage it, and I'm going to continue this. And I'm asking you one question at a time. There's no simultaneity. There's no parallelism here. But we're both alike. We are partners. One is not sub to the other, subroutine. We are co with one another. We're both active, and we're just exchanging. We're just having a conversation, taking turns. And that seems an incredibly reasonable thing to have in a programming language. But culture and history kind of nudged it out of the way. But we're kind of realizing that many of our concurrency problems are actually we're creating them rather than solving them. And just coroutines are a very simple way of doing that. And when we lock them into those other tasks that people say, well, this is why I was threading, it's normally something like asynchronous IO or timers and things like that. And once we recognize it's actually many of these things come down to a really simple class of problems. It's, well, right, why don't we just write a coroutine for that, or hide that away? And then suddenly life becomes a lot more single-threaded, which is a lot easier for us mere mortals to reason about.
Okay, those were all the chapters that I wanted to cover, but I was also really curious about the process of writing the book, because we've alluded to this already a little bit. There are many chapters written by other people, and then you wrote a few chapters also, and then you edited the book with the two of you. So how did you deal with different chapters giving conflicting advice? Were there chapters that were like mutually exclusive, like, oh, we have to pick either this one or that one? How did you manage different opinions? And because the book does feel like a whole that is somewhat consistent, I'm really curious how you did that.
We actually wanted conflicting opinions in various places where we didn't disagree with the opinions, I think. So, for example, like Kevlin just talked about checked exceptions, we were kind of interested in maybe a piece which was like stating why checked exceptions would be a good thing, when there'll be a good use case. With certifications, my colleague Mala wrote a piece about why certifications are very valuable. And I went out and sought a counterpiece to that, because I know a number of my friends and ex-colleagues are much more anti-certifications. Interestingly, by having those different points of view, you can actually come to, they don't necessarily contradict each other. So for example, the certification one was like, you know that the computer science answer for everything is it depends. So the certifications one was, if you need to do this, certifications might be a way to forge that path. On the other hand, if you're looking for a particular type of person, a certification is not going to tick these types of boxes. So it's quite good to get what looks like on the surface conflicting advice, because it actually helps you weigh up, sometimes it's this and sometimes it's that.
Yeah, and that was something that we were both very keen on, this idea that, although we have our own particular perspectives, as Tricia said, when there's something that is genuinely wrong, we're not going to do that. It's a case of like, should I sell my grandmother? Well, no, we're not going to have a counterpiece to you shouldn't, you should. That doesn't make sense. And if you're going to have an argument with the compiler, you're going to lose. In other words, anything that's syntactically wrong. So there is a kind of a right and wrong here. But there are so many things that are, it depends. And in those cases, just giving the reader, this is not a book by one person. This is a book by many people. And so therefore, we're trying to show you, sample the landscape and sample the views that are out there in 97 things. It's not a perfect sample, but we'd like to give you that representation. And that's quite important, because otherwise it makes it sound like there is a foregone conclusion, that there is a right answer in a case where actually maybe there's a bit more discussion to be had. And regardless of our own opinions on some things, we recognize, well, that's my kind of opinion here, but you know what? There are decent people who don't believe that or have some points to make against that. So we want their voices as well. So if this were a single book with a single storyline that had to be coherent, that would be a very different kind of thing. But we actually have an opportunity here to say, hey, look, here's the range of thinking. You, the reader, get to figure it out for yourself. And that, I think, is quite important, because in those cases where there isn't a fixed answer, you've got to show that the landscape's a bit bigger. As Tricia was pointing out, that these things are often complementary. They sometimes appear initially contradictory, and you can see a few things where they don't agree, but then you suddenly go, actually, there's more to this than meets the eye. And it's that multiple points of view that becomes valuable.
Yeah, and it is often, of course, it depends. What might be very good advice for one situation just doesn't really fit a totally different company or a different type of programming language.
And again, that kind of informs why we were really keen on getting some representation of other JVM languages. Otherwise, it does look like that, it's only Java. Well, no, it isn't. There's a lot of other things going on there. So I think that's quite important. And that's something you can do more easily with more people, which is the structure of the book.
As an editor, it's kind of challenging when you found pieces that you disagreed with, because you were like, okay, I don't necessarily agree with this, but is it that I don't agree with it because it's wrong, or is it I don't agree with it because it's against my opinion? And it was, as an editor, it was really eye-opening to have those sort of internal conversations of like, oh, I'm going to have to open my eyes to other points of view here.
Yeah, I think and so it's kind of interesting when we were going through, because we received all of these pieces, some of which people contacted us with, some of which we went out and sought. And there's a whole load of articles up on Medium that were kind of published through that initially. It was kind of like a trial space, but also people were able to submit through a form and Google Docs. So we're getting all these things in from different sources, different people. And obviously we get more than 97 things. So there has to be a decision process. So we had to, kind of from the beginning, based on my previous experience, because I edited 97 Things Every Programmer Should Know, one of the things that I found was useful is make sure that we limit the number of contributions from an individual, because otherwise there can be too much, no matter how brilliant their pieces are. That's the problem. Sometimes that's the most frustrating thing, is like somebody gives you all of these wonderful ones. And we had that more than once, people giving us loads of great stuff. But actually the whole thing is to give voice. So limit of 3, that was our cutoff. But that also boosts the number of people that ultimately get represented in the book. That's what you end up with when you sort of cap it. But it does mean that you're kind of looking, sometimes you've got 2 pieces of advice that do say the same thing, and you're looking for a reason to, decide between one and the other. And so Tricia and I had a number of conversations, some of the, different categories. Yep, this one's easy, this one's in, this one is easy, we're not going to include this one. And then we had this kind of gray territory, this in between, kind of like, oh, I like it, but, or we've already got too many pieces from this person, and so on. And those were the ones that attracted discussion. So, which I would never sacrifice that, because I think that's part of the joy of this. And you end up learning more about it. And we're each making a case. On the whole, we were pretty much on the same page. I don't really think we had any kind of like anything that was contradictory. We just sometimes would want to cast a vote for one rather than another, but we ended up with fairly much in the same space. And honestly, I'm going to say it was actually easier choosing these 97 with Tricia than when I was the sole editor of 97 Things Every Programmer Should Know. I probably disagree with myself a lot more. So it was kind of interesting, just that process, but you're getting somebody else's point of view, and it creates a balanced whole. And Tricia and I come from very different points of view when it comes to this. So that, I think, helps the roundedness of the book and the kind of what gets included and what gets represented and who is in there.
Yeah, that makes sense. Because as I said, from the reader's perspective, it does feel like a consistent group of tips or things. And even though sometimes within a chapter, different viewpoints are being presented, as a whole, it feels really as a consistent story. Are there any of your favorite chapters that I might have missed? So we've covered the ones that I thought were most interesting, but maybe you also want to say, well, if you are reading the book, then you definitely shouldn't miss chapter.
The editor card that I play for years, which is I don't pick favorites. And I wait for people to specifically raise one. That's first of all mine, because otherwise I know that what normally happens is either it's the thing that most recently occurred to me. It's like that thing when somebody asks you, what's your favorite film or what's your favorite? Sometimes you think you have a favorite, but sometimes it's just the thing you thought about most recently. And so you end up with a recency bias, which I'm not going to play favorites. I can let Tricia do that if she wants, but I'm not going to play favorites with this one. Yeah, no, I am going to make a recommendation. You see, there's 97 things, 1 through 97. Honestly, read them all.
That is cheating. What about you, Tricia? Do you have any favorites? Well, apart from, I guess, your own chapter.
So that's the easy answer as well. Mine are obviously my favorites. I'm a bit more general than that. One of the things I really liked, so I joined halfway through the project. I didn't start off the project. I joined to edit a bit later on. And one of the things I quite liked with what we had when I joined and the pieces which came a bit later on as well, is that we had a lot of stuff on automated testing and the value of automated testing, good ways of doing automated testing. And I'm a big fan of that because I kind of discovered automated testing a little bit later on in my career. Early in my career, I saw JUnit testing and I was like, I don't really get it because our tests were always failing. And so once I worked for somewhere where automated testing was like, it really worked and it really gave you the confidence to do your refactoring. It gave you the confidence to do these small commits that I was talking about later. Then I'm just passionate about anyone who can talk about why automated testing is a good thing.
Great. Then that concludes the episode for today. Where can we read more about this book? Of course, we have some links, I think, that we can put in the show notes, the link to the book. Other places where we can read something about?
There is a Twitter stream at 97_things.
Oh, great.
If I remember the joy of underscore 97 things, for some reason it originally disappeared. And yes, it is 97_things. So if there's any kind of announcements related, there are other books in the 97 things series, but we kind of, it has a slight bias to the Java stuff at the moment, the stream. There's also the Medium blogs, 97-things. You can dig around that and find kind of early drafts of many of the things that became chapters. And I think, honestly, if you just Google because 97 things is such a distinct number or such a distinct phrase. You'll find some of the other books in the series, but if you put 97 things Java, then it narrows it down really quite quickly.
Yeah, and we'll also make sure that we put a link, of course, to the Twitter, to the Medium blog, and to the book directly in the show notes, so it's easy for people to check it out.
Yeah, and you can find every now and then there's kind of little discussions that pop up. Trish and I did a Code Ranch thing last year where it was kind of the book of the week, and focused on that. People asked questions, we responded, and so on. So yeah, there's a few things around and about, and some very nice reviews that are not Amazon or O'Reilly based around. So yeah, there's the good stuff's out there.
Well, great. Thanks both of you so much for being on the show today.
Thank you.
Thanks very much.
This is Felina for Software Engineering Radio.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.